Good evening, good morning, everyone. So, guys, till now we have discussed everything in your managing partition and file system, and from today onwards, we are going to discuss about logical volume management or logical volume manager. Also, you can call it as a okay. So, what all things we are going to discuss under this one? We'll come to know what do you understand by logical volume manager or logical volume management, basically. Right, normally it's a manager, normally we call it as a, but basically it is a logical volume management, like user management is there, group management is there, right, and disk management we do. So same way logical volume management basically it is. So what do you understand by logical volume management, and how is the architecture of LVM, right? And then we are going to see some of the components of LVM, like physical volume is there, physical extent is also something normally they ask in interviews. Volume group is there, logical volume is there, logical extent is there, right? In term of logical volume, and then these are the set of commands which we'll see, right? Which we use while working with logical volume management, guys, or a logical volume manager. Okay, guys, let's start the session, right? So basically, logical volume management, this entire topic we call it as a logical volume management. But in general, when you are going to talk, so we call it as a logical volume manager. Okay, so it's a mechanism, right? Basically, to virtualize the disk, right? And that is what I have said in my previous videos also, right? So it can create virtual disk partitions, right? Out of one or more physical hard drive. Physical hard drive means what? The hard drive like iSCSI is there, right? NVMe is there, right? There are different type of disk type will be there, right? So from there only, from those physical drives only, you are going to create this virtual partition, right? And that allows, basically, it will allow you to grow, shrink, or move those partition from one drive to the other drive as you need the change. Okay, and it also allows you to create large partitions than you could achieve with a single drive, correct? Traditional use of LVM, that includes databases and company file servers. Basically, these are some of the example I'm telling you where we are basically using, where the actual use of this LVM is there. So in real world, in real time production environment, the actual use of this LVM have includes database basically. Okay, most of the time you are dealing with database directory. So there you need to include this LVM, right? And company file servers, basically files which are keep on growing, right, in the size. So at that, for the logs you can say, like for transactional related logs will be there. So for those kind of application also, or company is having so much of file server. Okay, so for that also they have to use this LVM where they are not sure of their data. So when the data will be keep on growing, right? But even as a home user, if you want the last partition for music, videos, collection, and all, okay, in that case also for storing online backups, okay, at that case also you can use an LBM can be also convenient way to gain redundancy without sacrificing flexibility. Okay, so ultimately, the main purpose of your LVM is you can say in case of in production environment you can say for the database, right? Because your database, we don't know when the data is unstructured data will be there, like your for MongoDB it is there, right? These are the simple DBs there, right? Or these type of relational database, like these are non-relational database services. So in this case the data is unstructured, so we are not sure of what kind of how much data we are going to get and how much basically our directory is going to grow, right? So you can see from here, guys, it's clearly like why I have written like this, you can understand from here, right? So there is a reason behind that one. So we have already know about so under topmost level, like forward slash, you can create your own data directory. Basically, this data directory is for your files and all, right? For your company who is having file server, right? So who is maintaining a lot of files and all, and company who is maintaining database and all, right? So obviously, all the companies are, these two are common things, right? And this is something which you are, if you have to do the monitoring stuff of your application, right? So of your database also, then you need log monitoring tools, right? So for that also in varlog, you have to make sure these three directories, right, is mounted on some kind of a partition, right? If I'll tell you these three directories is mounted on different partitions, basically, so that will be coming, that we cannot say directly from here. Okay, so that will be coming from here, right? So the physical volume, correct? If you say you have a physical volume of Dave slash SDB, right? And SDB is having almost 1 TB, correct? Right? Yes or no, guys? Correct. So I am allocating a physical partition of 1 TB. This is the physical partition of your 1 TB. Correct. So when I am telling you can keep on grow, shrink, right? Or you can move those partition from one drive to other as you need the change. Means if suppose this physical drive, okay, or is faulty, okay, so whichever the physical volume is created from this physical partition, okay, you can move also, okay. So and even in this case also, if suppose from this logical partition, right, so from this logical partition, if you are allocated, okay, if you created basically multiple logical volumes, right, so that also you can do it. So why I'm telling, see, these three words are very, very important. The first word is allowing you to grow. Okay. So if I'm telling is, for example, this data directory is mounted on this LVM. Okay. So I'm using this LVM basically, right? So, and in this LVM only it is mounted. Okay. So I can grow. So earlier, if the size was, for example, if I'm telling the size was 1 GB or it is 10 GB, I have allocated to this logical volume. I have allocated some 10 GB. Okay. So 10 GB is allocated to this data, right? So in this one, this is a file server. So it is keep on growing, right? These three words again I am why I'm forcing on these three words. So if it's keep on growing, so it will reach to 10 GB. So at that time you can again, right, grow this particular logical volume, correct? And if we see, okay, those 10 GB is not of use, or out of 5 GB I can zip, okay, or even I don't need this data directory anymore. So in that case also I can unmount and even I can remove this LVM. Yes or no? Correct? Right? And in
Yes.
case that is what called shrink, or move those partition from drive to drive. So suppose this physical volume is faulty, okay? So in this case, I can move this physical volume. So whichever the volume group is mounted, okay? So I can move from old PV to new PV. That also you can do it, okay? So this is why the definition we are calling it as a, it creates a virtual disk partition out of one or more physical hard drives, okay? Allowing you to grow, shrink, or move those partitions from drive to drive as you need. Okay, now coming back to the point, okay, how the logical volume manager works over here. So if you see this diagram, guys, with this diagram you will understand. So first of all, now this part you guys are very confident, correct? From managing partition and file system, so at least you can tell, right? So all we know that this is a disk which is going to assign to your system, right? Basically, you, some storage team has assigned 1 TB to a physical disk to you, correct? LN is attached to your Linux server, right? Now from here you have to start creating the logical volume. How the process evolve over here is, so the first point is, see, we can bypass also, that also I'll tell you how we can bypass the things and all. But ideally how you have to go, okay, so if this physical volume is of 1 TB, So from this physical volume only, okay, you have to create your, sorry, this physical partition is 1 TB. So from this physical partition only, you have to create your physical volume. Okay, this is the actual process I am talking about, and this is how it has to be. Okay, so this is why I have written here physical volume. This is a physical partition, dev slash sdb. It's not one or two or three. No, I am fully assigning one physical disk I'm giving to you. Now from here, you have to start creating the physical volume. So physical volume, okay. So I do one thing like this physical volume, okay. I am going to assign 10 GB. Understanding my point, guys? This physical volume, I am going to assign 10 GB. Okay. See, that is Dave SDV1 and Dave SDV2. That is still you can call it as a partition, according to me,
Mm.
because you need to convert. There is a command pv create. Until unless you don't run that command, Sagar, it's not going
Mhm.
to convert into physical volume. But if you are telling slash Dave
Okay.
slash SDB1 is a physical volume, no, that is wrong. Absolutely. What I am telling is that is a physical partition basically. What you have done is
Got it.
from a longer disk, if I'll create out of this disk only. From this disk, if I am telling is I am going to create slash dev slash sdb1. Okay, let's remove this one. Okay, let's remove this one. Correct. So from this only, if I have created of like 500 GB. Okay, 500 GB of one slash dev slash, correct. And again from this only I have created another of 2. Okay, that is 500 GB another. So but is still it is a part of physical partition, right? Because I have not converted that
Mm.
into a physical volume. So to convert this one into the physical volume, you have to run a command. Okay, what is that command? So that command is called pv create. Until unless you don't run that command, Sagar, you won't be able to create that one. This is the actual process. Okay. Okay, now there is another process when you said this one. So few of us, what they will do is directly, rather than how they are going to bypass thing, so they are directly going to add this to a physical, sorry, volume group. Understanding my point? So by default, your physical volume will be gets created. That is also one way, but I don't suggest to go it like this if you are a very fresher to this one. If you know, then only go, because this I'm keep on telling. Because when you run immediately this command now volume group, when I'll show you this practically, you will see PV will be gets created by default. Okay, so when you create a VG group, okay, VG create, by default your PV will gets created. Okay, that is a bypass basically. But the way is like from this physical volume, okay, if I want 10 GB of this physical volume, okay, so I can create a 10 GB of this physical volume. Okay, I want another 10 GB of, okay, of physical volume PV 002. Okay, 02. Okay, so it's going to be like that. And from here only, let's create a pool of volume group. Let's create a pool of volume group. So here volume group is basically working as an intermediator between your physical volume and your logical volume. So what I am doing here is all the physical partition I am converting it to a physical volume, and from this physical volume I am putting it into a volume group. Okay, I am telling let's add this one into a pool of volume group. Why I am doing it like, because I have to keep all the things at one place, right? When you have to do some intermediator, like there is a centralized system, right? So from the central system only, if all the farmers, if they where they are going to submit their basically all the weeds and all, right, their crops and all, where they are going to do that one, so they have to keep it in some warehouse, right? Correct. And from that warehouse only it will go to the different part of the world, sorry, part of the world also, you can say, in term of exporting, and in India also, right? From there only all the wholesaler or whoever is there, they are going to buy it, or different big companies are, they are going to buy it from the government, right? So first all the farmers, where they are going to give their crops and all. So that is what recently in India, right, you have heard. So government is going to buy their, right, all the crops, right, basically. Yes or no, Sagar? So from that central only, they are going to allocate to rest of the India. From if it is going to a normal consumer or if it is going to a multinational company or wherever it is going, right? But one center is there, right? From that center only it's collecting, and from there they are distributing across the India and out of the India also. So this is the best example of centralized system. This volume group is basically working as a pool kind of a thing where you are storing your physical volume, and it will become a volume group. And for that you need to run a command called vg create. So once you will convert this one into a volume group, from these volume group only, now you will divide into smaller chunks. Okay, why we are doing this one? Because see, when if I have created a logical volume, okay, and now as of now I don't need, as of, I know that it's going to be hardly take 5 GB of data, okay, or if I take 10 GB of data, okay, so 10 GB is already full. So from 10 GB this logical volume will look after where? It's going to look after in this volume group only. Correct. This logical volume is going to look after where? This logical volume has to look after where? It has to look after at your volume group only. Understanding my point, guys? So it's like this only. So when this is basically, this will be of your 10 GB, right? If I 10 only I'm telling you, because once it will be here, it will be more, okay? And if let it be like 5 GB, okay, you can see it doesn't matter. So this has no relation with this. So you can keep adding your volume group right, from your physical volume. That is what I am telling. You can keep on increasing this part. This is more important for us because it's a intermediator, right, between logical volume and between physical volume, right? So if this is 5 GB, immediately if it is allocated to whom? If it is allocated to this part, right? So if this will be full slash data directory is if it is mounted on LV001, okay, you are using this logical volume basically, okay. If it is this one you have mounted on this logical volume data directory, and if it is full, then in that case this logical volume it's again going to take the space from your volume group only. Same way for this also, right? Same way for this also, right? Correct. And also this entire thing we are calling it as a single logical partition. We are naming it as a logical partition. Understanding my point, guys? Yes or no? Okay, now again you are coming to the same definition. What is the definition of your this one logical volume? I said you can reduce shrink at any point of time without disturbing your data. That option is not
Okay.
available with your partitions, physical partition formatting and all. Okay, but with the logical volume you can do that one. This is why we are calling it as a mechanism. Okay, and why this is so effective, still it is effective. None other mechanism, I would say, as of now, still in cloud also we use this one. Understanding my point, guys? Okay, so see, if this logical as much as you need, okay, if I need 5 GB extra, it will be get added to this. I can extend this logical volume. Okay, I don't need that 5 GB now. Earlier it was 10 GB, so I want to reduce another 5 GB. You can do it, but your data is intact. Your data integrity is more important, right? That is what we learn in our company, right? Data integrity, right? Why data protection? All the time we talk about data protection, data integrity. Your data should be safe, right? If this is a client data which is very very critical, I said we are going to use it for all file servers, we are going to use it for database, right? So you need to make sure you have to give them a mechanism or a tool, or basically this is a technique, okay, or this is how the LVM designs. Okay, so where we can grow, shrink, and move also. Even you can delete your LVM also if it's not required. So you can save your data, right? So it is more effective, guys. Correct.
So here basically we are moving. Suppose this LV01 is faulty, so we
Hmm.
will move the data, or we will move the drive complete data of that drive to LV02, right?
That scenario I'll come to know, okay, because how it is related to your volume group. Because see, when if it, I said this is
Mm-hmm.
complete a process, right? Correct. So if you have to train
Mm-hmm.
bogies there, now train set is coming, right? Vande Bharat Sagar, right? That is a train set. But earlier the coupling was system there, right? So if you have to move one middle bogie, you have to take out from starting, right? You cannot simply take out, okay, I can take out this from here, right? And I can shift somewhere else.
Mm-hmm.
No. Correct? Understanding my point? Because it's a coupling to each other. Okay. So this is coupled with this coupled with this. So the coupling has to remove sequentially. It's not like that, okay, it's in my movies, if I come something, I can do something. No. This is why it is so critical to reduce something, to move something. And these are the interview question scenarios they are going to ask normally, okay, in interview.
And we format this logical partitions as well, right? Logical volume.
Yes,
This.
yes, that is what it is exactly the same way how it is also a file system type. Okay, if you, that is what I said, you need to change the ID type, you have to do the file formatting and
Mm-hmm.
all, right? Same way what we have done it for your physical partition. If you need it for like ext4, ext, we do the partition for your physical volume. We formatting for your physical partitions basically what we have done. Same thing we need to do it for your logical volume as well, that I'll tell you. Okay. So
Mm-hmm.
there are few commands, guys. So now you understand what do you understand by LVM. How is the architecture of LVM? So physical volume is there. Physical extent is something which I'll explain. Volume group is there. That is what you have understand. Logical volume you have understand. Logical extent will be there. These are the commands which is important. We'll see from tomorrow. So PV is your physical volume, okay. VGS your volume group. LVS is your logical volume. PV display, it's going to be your detailed display of your physical volume. VG display, detailed display of your volume group. Physical volume you have to create, volume group you can create, logical volume you have to create, right? You can extend the volume, you can extend the logical volume, you can reduce the logical volume, even you can remove the logical volume, you can remove the volume group also, you can remove the logical volume also. But there is a sequence again, you cannot simply go ahead and do it, okay. So yeah, so like this, and there are will be real time scenarios. All these real time scenarios will be going to see from tomorrow onwards, okay. And yeah, and all
Okay.
issues related to logical volume also we are going to see, or interview questions what they are going to ask in interview, that also we are going to see. Any doubt in this one, guys? This architecture itself is important. If you understand this architecture, your 50% of the LVM is done. Okay, guys, I'm ending up the session here only. Thank you for staying connected with me. Let's connect again for the next topic. Till then, just take care of yourself, your loved one. Bye bye and Jai Hind.